Hello and welcome to the TRILUX Academy. My name's Helen Looms.
And my name's Jamie Yates.
Today's Academy training module is looking at lighting for car parks.
In this particular Academy on lighting for car parks, we will be looking at lighting distribution for car parks, placement and refurbishment, and we'll also be looking at investigating the variation in typical controls that you can use, from basic types of controls right through to fully interactive controls that can maximise both the energy savings and help facilitate a refurbishment potential.
We'll also be looking at some research that focuses on mega trends within car parks, and we'll also look at a couple of case studies to show what can be achieved, and then we'll have a brief glance into the future. If we look at multi-storey car parks, most have hardly any daylight, they can be dirty and fairly oppressive environments.
And this is where security and a feeling of safety has a huge impact on the use and take-up of a car park. So if you have a dark environment there where you are not feeling well lit, then you may not use that car park as much as you would maybe a very well lit car park. So there is a huge impact on this matter.
Lighting can be intelligent and innovative.
By using a most basic level, you can utilise presence detection, not necessarily daylight control, and this will then allow movement to be picked up both by pedestrians and by vehicles. This then allows a heightened feeling of security because you also know that the area that you're in is being triggered by anything and anybody within that space. So therefore, once it is triggered, you're increasing the light level in the space and therefore giving you that sort of heightened sense of security, which is predominantly an issue in car parks.
It also means vandalism will be reduced as well.
Indeed, so anybody within that space who is going in there is fully illuminated.
Our cities already have many car parks in situ that are functional, but they probably don't have that feeling of safety. So many of our projects are actually refurbishment projects.
The difference between refurbishment and new build in terms of the luminaires that are used is not that great. However, it's where the controls methodology comes in can differ from a refurbishment to a new build car park. But either way, the installation method is very, very easy, and therefore in both cases, both on new build and retrofit refurbishment, there is a very good financial case for an upgrade. Lighting car parks at entrance and exit areas do have specific requirements and needs that do actually vary throughout the day. So you're coming from a very bright outdoor environment into a relatively dark space, going from maybe sort of 10,000 lux down to 75 to 100 lux within the deep part of the car parking space. So you need a transition area. In the same way that if you then flip that around to night time, you're then coming from a space that is inside illuminated, going to an outside space that is going to be very, very dark. So again, you need a sort of transition period. It's also an area where you also might have a higher level of pedestrian access. So there's also areas of safety there that you need to consider in terms of the conflict zone between a vehicle and also pedestrians that might be either leaving the car park or near the pay stations.
So we've got to allow our eyes time to adapt.
Absolutely, that's one of the key criteria, not just in terms of the guidelines, but also in terms of good practice of lighting a car park, whether it be underground or a multi-storey car park. The other area that gives a little bit of area of complexity are the ramps. Yes. And the difficulty here is that as you are going down a ramp, and if you've got luminaires on the ceiling, then in effect there are certain positions where you are at eye level with the luminaire that's maybe 20-30 metres ahead of you further down the ramp. So there's an element there of glare control that has to be taken into account.
And you're approaching the luminaire at the angle that it's not designed.
Exactly.
You're coming straight into the glaring.
Yeah, so you have an issue going down a ramp, maybe not so much of an issue going up a ramp, but definitely downward ramps do raise this issue when you're looking to design it, but it's also a very tight space as well. So sometimes these ramps are circular, tight corridors, or maybe it's a straightforward straight ramp, but you've also got two-way traffic on those straight ramps.
So you have to be concentrating, you have to be alert. But the key is the distribution from the luminaire.
Yes,
has
indeed.
to be considered.
Yeah, it's a key item here on the ramps.
Atmospheric conditions in car parks could mean we've got to have very special requirements. There could be damp, corrosive atmospheres, open to the elements, usually dusty and dirty.
Yeah, so generally you're looking at an IP65 or an IP66 luminaire to ensure that the luminaire can be cleaned down over the installation period, but also that it's not going to get a build-up of dust and dirt inside the luminaire as time goes on.
And also be able to withstand those slightly hostile environments.
Indeed.
Car parks are starting to be considered as an investment. There's such a high value placed on land within cities, so now we have to think about multiple level car parks, and these are places that people can charge serious money because they're necessary to all of us using cities.
It's also the space itself within the city centres. If it's not generating enough revenue, then it may be more worthwhile for that particular investor to turn it into a apartment block or a particular development. So therefore the charges are going up on the car parks, but therefore also the expectations from the users of the car park go up because they're having to pay more for that space. The
more money you're paying for it,
Indeed.
The more you demand in return.
Yeah.
There's a very interesting study that looks at the future of vehicle parking management by a company called Frost & Sullivan. And they've conducted some market research which has resulted in some interesting megatrends as they see it. Now, the study was from 2013, but some of these trends are still valid today. Frost & Sullivan have identified the megatrend urbanisation. This is because more people are being attracted to cities and therefore even more parking spaces are being required. Deep plan car parking spaces take up a lot of room and they're not popular with the users. Trying to find your car in a vast open space is never easy. So underground and multi-storey car parks are becoming more popular.
With the advent of a restriction on space for development, historically underground car parks have been very, very expensive, but more and more is actually happening now where those car parks are going underground to allow for other services or other facilities to be built on top of those car parks. So we're seeing a sort of take up of the underground car parks rise over the multi-storey.
Another aspect of car parks that Frost & Sullivan have identified is this electric mobility trend. We're moving more and more towards electric cars, and they think that there will be about 200 million electric cars by 2020. So this means that all of these cars are going to need a charging point. So there's another demand for this. Maybe they're going to be in separate areas of the car park, and maybe you could charge more, or if the governments are trying to encourage us, charge less.
At the moment, electric charging points within car parks tend to be on the ground floor because of the ease of access of installing these electric charging points and also getting the cables in. But one of the big factors for the uptake of retrofit refurbishment is a lot of these car parks have restricted input coming in from the electricity network, getting the size of the electric cables that they need onto the site. And by putting electric vehicle charging stations on there, they would go over that particular threshold. So by putting in an energy efficient lighting scheme, it then releases capacity on their network on that particular site to then allow them to then put on the electric charging stations.
In addition to saving energy.
In addition to saving energy. So that is one of the good sort of growth areas where refurbishment of lighting is actually then helping the increase in the electric vehicle charging points. The other part with the electric vehicle charging points as well is it increases the dwell time that people are spending on the car parks and how long they're leaving their cars there for, because they need to have them on there for a minimum amount of time to be able to charge their vehicle. Whether that continues or not, I don't know with the battery technology, but
very welcome to the shop owners as well.
Indeed, yeah, absolutely.
The really interesting megatrend is connectivity. All of our mobile devices are now capable of doing many, many functions. And this is going to lead to online payment systems, some of which are already in existence.
Yep.
But you could perhaps use your mobile phone to find a parking space. It could be that you're going to get information on your phone about ongoing public transport systems or even local attractions.
Absolutely. One of the other elements that sort of connects onto this, but we'll cover this later, is automated valet parking, which companies like Bosch are working on at the moment with the likes of Mercedes and BMW, which is another sort of element to the connected and connectivity within car parks and the vehicles themselves.
It also means that the running light can give more information as well via your mobile system.
Maybe even through giving a Wi-Fi signal down on underground car parking to give that connectability through a Wi-Fi network.
And this information back to your phone can really reduce the amount of time you look for a car parking space.
Absolutely.
As well.
So energy efficiency is a key part to car parks because we've got high volumes of light and lighting within the space. It tends to be the biggest part of the energy bill for a car park, whether it be underground or overground. You tend to be looking at return on investments of and payback periods of about 2 to 3 years if you're looking at retrofit refurbishment. Can be a little bit longer if you're talking about existing T5 technology, but there is a lot of car parks out there that are still operating T8 technology. There are also early adopters that have maybe put in LED tubes into their car parks that have subsequently found out that that was maybe a wrong decision 2 or 3 years ago and a perceived quick fix.
So it's not just the luminaire that has to be energy efficient, it's the control system as well, so that you're only using the light when you need it.
Absolutely. So it's the integration of efficient luminaires along with correct lighting controls that's correct for the application. And you can have variation in the controls between public car parks and private car parks. So public car park, you don't want to have the space go into dark. You want to maintain a certain level of light, but we'll cover that later. Whereas private car parks, you can actually educate the users or maybe the employees on a private car park that a leading light might put it back to zero, put it back to dark, but it gives them that expectation as well.
There is another study from 2013 by APCOA, which they updated in 2016, which is really interesting because they are looking at how long it takes somebody to find a car parking space, how many times you're driving round and round.
Drive around the block.
Round and round. You know, how much energy and time are we wasting just looking for a car parking space? They say that 40% of urban traffic is made up of people looking for a car park space. Huge amount. And before they even set out, 9 out of 10 people think about where they're going to park their car.
Yeah, no, I do. So actually, if you could automate this process or it could guide you to a parking space, then not only are you saving energy in terms of the lighting technology you're putting in, but you're saving it in terms of the carbon footprint of the car.
Yes, and also frustration.
True.
Another area of interest is looking at how people will use their cars. Sharing is an obvious solution, and maybe carpooling will become more popular. Of course, when we get to fully automated cars, you phone up your car and book your automated taxi, which will have its own parking space booked for when you get to your destination. Who knows?
So we've covered a lot of the sort of beautiful dream of car parks, but the reason behind this is there is a harsh reality.
Yes.
And that is car parks have no to little natural daylight, especially if they're underground. The lighting is historically generally poor. You've got tight parking spaces, you've got difficult orientation, you've got pillars to cope with, you've got tight ramps to cope with. But what you're trying to do is sort of gain a sense of appearance within the space. You're trying to encourage people to use the space. You're trying to make them feel safe and secure.
Yes.
Trying to allow them not to damage their car in the process. And just to basically make life a lot easier so that if you're utilising a particular car park, it's actually almost a pleasurable process. What we'd like to look at now is a case study.
A case study. A lovely case study in Australia. Of course, it's a different environment. And this case study is looking at a 3-storey building with open architecture that is anything other than just a dark space. Consideration has been given to high performance features, especially which are especially useful in these subtropical areas. So they have very warm, damp summers and mild, dry winters. So the luminaires must withstand these weather conditions. Also, they have to have a very high energy efficiency with high lumen output and great light distribution. Therefore, a system using IP66 luminaires was used. These luminaires had a very broad distribution, so it resulted in a very large area, open, well-lit space that withstood the elements of the weather.
As you can see from this picture, this is the entrance area, one of the transition zones that we spoke about earlier, where you're coming in from the outside into the interior of the car park and then through to a much lower lighting level. So here we've got the Morona luminaire that's been used to provide a very high level, lux level within the particular transition zone, where you've got the barriers. I think just off to the side there you've also got payment machines. So again, it is one of those areas where you've got vehicle and pedestrian interaction. The Griffith University and the authorities in that particular area said that they needed uniformity, not uniformity in terms of lighting, but uniformity in terms of appearance.
Yes.
On all the car parks in the campus, and this particular car park was the first one to be done. So therefore it sort of set the standard for the Gold Coast University car parks to be upgraded, refurbished, or even newly built. So another case study is a spiral underground car park in Ipswich, close to my home. This was quite an interesting one where you actually don't have any continuous, or it is a continuous ramp, you don't have any straight line areas within the underground car park.
So one of these circular continuous
Circular
ramps.
continuous all the way down. I think it goes down to about the equivalent of about 6 stories. So it's quite a deep car park. Quite difficult to light in terms of uniformity, because you've got an inner circle that is a different diameter to the outer circle.
Okay.
But using an XB optic from, I think it's the Olivian luminaires that we've got on this particular car park, it was a good point-for-point replacement scheme. So we're basically taking out old T8 luminaires and replacing the exact same position with an Olivian XB optic luminaire, with certain elements of lighting controls. So this had a setback functionality where it'll hold 20% lighting level when there's no detection of vehicles or pedestrians, and then when there is a detection it will then ramp up to 100% light output over certain groups. So it would sort of do maybe about 50 metres of the spiral car park either way of the detection zone.
And with this style of car park you don't have an entrance and exit ramp?
No, the whole thing is on ramp.
But it's a very shallow ramp.
Yes, indeed.
So we don't have quite the same problems.
No, so you're not dealing with glare issues on the ramps in this particular occasion. You do have a transition zone, which is obviously coming from the outside to the inside, where I think on the entrance area you're looking at around about 200 lux on the entrance and exit area before you then go into the main sort of depths of the car park, where you're generally looking at about 75 lux on the parking space in the roadway. One of the other parking projects that we've had the pleasure to be involved with is a European rollout programme. This takes into account a number of different car parks over a number of different countries for a very large car parking operator. A couple of images that you'll see here is one of the example car parks that we've got. It is mainly a point-for-point programme where we're replacing existing T8 luminaires with a new upgraded LED luminaire system. IP66 with integral controls. These actually utilise a swarm type technology where you've got sensors within not all luminaires but some of the luminaires. These then trigger a series of slave luminaires. So what will happen, again a bit like the spiral car park, is you have a setback level, so the car park is illuminated to 20% of the real output, and then on triggering of a sensor within one particular luminaire, that will then trigger a group of luminaires to then ramp that up to 100 lux. This particular car park owner is, I would say, sort of in the upper echelon of car parks, whereby they've got freshly painted floor surfaces, good reflectance values, really good and nice environment to actually go and park your car in.
When we look at the solutions, it's sometimes really interesting to play with the optics that are available to you, because it might surprise you. A very broad distribution optic is great for lighting vertical surfaces and faces and creating that sense of safety, and also gives you the uniformity across the space. But sometimes you might have to put in more luminaires to reach the light levels that you want. So the capital costs could be more expensive, but your running costs are usually a lot less. When you start to look at more direct optics, narrow beam optics, you can achieve a higher level because the light is more direct. So therefore you need less luminaires, but the uniformity is less. And there's a comparison tool on the TRILUX website that allows you to drop in different optics to see the result that you can achieve.
Generally, you'll find car parks in the main tend to have a ceiling height of around about 2.2 to 2.4 metres, which is quite a low ceiling height. So with this particular tool, you can also you can look at the ceiling height variation, and a wide beam optic generally works very, very well in your typical car park with a low ceiling height.
A simple control system can reap many benefits and can result in energy savings up to about 80%. It doesn't have to be complicated. This could be an intuitive control system that dims down using daylight levels, so it will react to the amount of natural light coming into the space, and also react to presence detection. As somebody walks into the space or if a car enters the space, the lights can ramp up, and it can be totally intuitive. It doesn't have to be part of a building management system, and then therefore you can keep the costs down.
You can also add onto that type of controls with the PIR, and not necessarily daylight detection, but occasionally daylight detection on multi-storey car parks. Swarm intelligence. So this is whereby a luminaire will wirelessly communicate with another luminaire, which is very, very important for the retrofit refurbishment side of business, because you don't want to have to rewire a car park. You want to be able to take a luminaire down and put a luminaire straight up again. Having the swarm technology allows you to maximise on the lighting controls, but also to maximise on the design and the feel of a car park. So this is why we tend to use a lot of sort of setback functionality, where you're maintaining a light level when there is no presence. But if somebody walks into a space coming out of a lift or from a pay station, they're not coming into a space that is in complete darkness.
So you're looking at about 20% of light levels?
It depends client to client. So some use 20%, some want to use 10% to maximise more on the energy efficiency. So it is a balance, but it's also what clients you're looking to aim for as well. So sometimes maybe if you're looking to capture the sort of the more expensive clientele, then it is maybe that you won't dim down the lights at all, or maybe you'll just dim them down to sort of 50%. So a little bit less noticeable. But
the swarm technology is allowing people to enter a space, the light in their immediate facility is on, but then also some of the lights in the adjacent spaces are on, to give that feeling of safety.
Indeed. So say for example you had a deep car park, so the whole car park would be lit to say 20%, and you might be able to see 200 metres across a car park. So you can still see the space, you can still see if there's anybody moving around in that space. But the area around you, which can be determined by the size of the swarm, could say, okay, where you are and where you've just exited will come up to 100%, so it gives you the right light to walk across the space, to get into your car, to load shopping into the boot, whatever the task is that you're carrying out.
And does this also respond to vehicles entering the space?
Vehicles, people, animals, trolleys, it has to pick up everything. So generally these will be done using microwave technology, not necessarily infrared technology. You have to be a little bit careful with the microwave technology, because also it can go up through the concrete floors of the car park as well and detect the space above. So that's part of good luminaire design as well, is making sure that the microwave detection only happens within the space that you actually want it to as well.
But we could use luminaires to integrate so much more technology.
Yep.
We're looking at introducing CCTVs, Wi-Fi.
Speakers.
Yeah, looking at where the hot spots are, and then heat mapping.
Yep. You can also introduce Li-Fi technology, which is obviously very valuable in underground scenarios.
Yeah, but the key to all of this is the data. This is where it becomes really valuable to the end user. Data is crucial in the digital economy, and the data produced by car parks will have a major impact. In fact, it will be worth its weight in gold. Every time a car enters or leaves a car park, it leaves a data trail. The date and time that the car entered and exited, how much the driver paid, the method of payment, these are all recorded. By capturing the data, the customer's behavioural patterns can be analysed and interpreted. Modern cars are becoming even more connected, and future choices on parking might be made by the cars rather than the drivers. Car parking machines may become a thing of the past, with parking paid for through apps or the car's registration number, which will become a virtual ticket for all parking transactions. This will further feed into the data reservoir. If analysed properly, it will lead to car park demand predictions and historical data can then be used to predict the future use patterns within a car park. Fewer people will own cars and will utilise car clubs, ride sharing and ride hailing as their preferred mode of transport. Car parks might also become hubs for the final mile journeys, be these by bicycle, scooter or on foot, and will be further driven by the generational change as younger generations adopt new concepts of mobility.
So automated valet parking is quite an interesting one, and this is one I've been following myself quite keenly. This is basically being developed by Bosch, I think being experimented with by the likes of Mercedes and BMW and some of the major German car manufacturers. This is basically where the car will go and park itself, and then it will bring it to you when you are ready to pick it up. So how does this change the actual car park itself? It means that whilst you will have an entrance and exit barrier, you will also need to have almost like a lay-by valet drop-off and pick-up zone as well. So we foresee that this sort of valet parking area will be sort of probably highly lit, because you're going to have again a transition zone with pedestrians and vehicles. It might be manned or it might not. You might have somebody there to help load your luggage into the boot of the car, not too sure. But what this does mean is that the car parks themselves could even be lightless. So if the car park itself is not manned and the car is parking itself, you then might have a car park that doesn't require light, except for the point up to the valet parking. What it also means is the car parks themselves could actually be more densely populated.
Yeah.
So the cars can go and park themselves maybe 2 or 3 deep, and then when somebody using an app or whatever the methodology is calls their car, the car can extract itself from its parking bay and go and be picked up by the driver.
So
or it might even be sort of able to move other cars around to remove itself out of the way from behind another car.
So you get all these stacking systems.
Yes.
And yes, and cars will cooperate with each other to move out of the way.
Yeah, so not only could you do it on one plane, but you could also do it on multiple planes. So as per the picture you see here, you've got stacking of vehicles using a lift method. So valet parking, quite an interesting concept, and I think it's something that could really, really change the world of car parking, both in terms of how a car park is laid out, the amount of vehicles you can get in there, and from our perspective, how a car park is lit or not lit.
So this is interesting. As we move to the future, the quality of any car park environment could become very, very important, not just the lighting, the whole atmosphere. So this could set your design feeling for an office or a shopping centre.
It's an extension to the space.
You're creating your brand values from the very first moment when somebody parks their car. These could be beautifully decorated environments. You could even have carpets, a bit like a car showroom. And why not? Why can't we have our car parks giving us that kind of quality of feel for the future?
So the image you see here is actually of a Bentley showroom in Westfield in London. But actually what they've got in the car park beneath Westfield is actually the pickup zone for cars you want to try out. So if you would like to go and try a Bentley, then you will go to the showroom. The showroom is quite small and compact with only a few cars in it. But then if you want to go and test drive one, then you go to the car park that is directly underneath it, and they've got a specific valet section within that car park where you will go and pick up your Bentayga or your Continental, take it for a short drive around the Westfield area, not get up to huge high speeds, bring it back, and then go back into the showroom again and be able to design your car on screens or pads, because that's also how a lot of the car showrooms are going, where they're going to these city centres where there's a lot less vehicles within the space, but they do need to have vehicles for people to try out. So exactly as you say, it's an extension.
And although this is a separate area to the car park, and it is beautifully decorated and has all very high quality finishes, interestingly, the lighting is exactly the same as the rest of the car park.
Yes, they've continued it through. So we've got a theme, and more importantly, there's a brand presence from both the showroom right through to the sort of the valet pickup area. So we've scratched the surface on car parking.
But we hope we've given you some useful information on the potential of car parks. And to find out more about the Academy training modules, please visit our website or register for our newsletter. And thank you very much for joining us. Goodbye.
Thank you very much. Goodbye.